Hello, this is part 3 of homework 8, where we first enter the embedded command shell, which is done using this batch file. So once I click on this batch file, this command shell opens up. As you can see, Intel FPGA embedded command shell. Once you're in this command shell, you can input the file path to where your HPS GPIO file is, and then you can run this command make, which helps us generate the executable ARM file. You can also use this command ls/l HPS_GPIO in order to figure out the file size that was just generated using the make command. This batch file, the file path for this batch file is also here, Intel FPGA/20.1/embedded. So once this make file is generated, and you can see that the make file was generated in this folder, because this is the folder where main.c is and make file is. So once this file is generated, I copied this file into the microSD card that's currently mounted on the FPGA board. So what I did is create a folder which was named home, and created another folder /root, and inside the root folder I have all 3 of my executable files that we run for this specific homework. So first we burn the Linux OS image onto the SD card, which helps us run a Linux operating system on the FPGA. So after you enter the Linux operating system, you can first figure out all the partitions that the SD card has, and these are all the different partitions that the SD card has, and these are their IDs and the systems on there. So this one is where the Linux system is. This is the partition where the Linux system is stored, and I think this is the one where all my files, my ARM executable files, are stored. So once we figure out which partition that we're gonna mount our home/root directory on, we can then run our executable files. So first we mount the SD card to that specific partition using this command mount/dev, and this is the partition that we want to mount it on. And then I also generated this Linux folder, this Linux directory under mount. So once you do that, then you can use this command, which helps us mount that specific SD card partition onto the Linux file system. So that's why when I try to mount it, that's why you see this message is already mounted on mnt-linux, and see, according to it's already mounted on Mount Linux. So once I have it mounted, then I can go into mount cd linux. This is the directory I created, and home, root are already existing because I made them on the microSD card when I was copying my files. So when I look into this, when I type ls, I should see all 3 of my executable files. As you can see over here, AES128 HPS_GPIO, my first _HPS. So after I have these files, I can, in order for me to not mount the SD card every single time, in order for me to run these files, what I did was copy these files using this command. So this is just an example of where I copied AES128 to the internal Linux file system, so that again I don't have to mount the SD card every single time in order for me to run the file. I do need to mount the SD card every single time I change the file, because those changes are not stored into internal Linux file system. So once I store all these files in my internal Linux file system, which is the home root directory, I also can check whether those files are copied correctly. So I did ls/l/home/root, which shows me that all 3 of these files, AES128 HPS_GPIO and my first _GPIO, are all there. These are the same files that were on my SD card partition. So I can run the command to show you that HPS underscore GPIO works. So first I also made this file an executable within the internal Linux file system, so I can just run it using /HPS underscore GPIO. So if I run it, you can see that it works correctly. Press the key to control the LED. So we can press this button. And as you can see, every time I press the button, the LED stays on. If I let go, the LED turns off. So press it 4 times, 1, 2, 3, 4. Then I'll run the command again in order to show you that the LED flashes twice before it gives me total control of the LED using that button that we just used. So I'm about to press enter and you're about to see the LED flash twice. As you just saw, the LED flashed twice, and also prints the message. The LED flashed 2 times. User key test. Now it's allowing me to press the key to control the LED. So if I press it, the LED will stay on as long as I have the button held, and when I leave it, the LED turns off. So, and that is it for this video. Thank you.